Today we're going to talk about the Internet of Things.
The Internet of Things, commonly abbreviated IoT, is essentially a network of devices connected via the Internet. This connection allows instantaneous collection and sharing of data between devices. Devices can be individual entities, for example, a heart rate monitor, or a component of a machine, for example, a sensor on a jet engine. Devices, often called sensors, generate tons of data, an estimated thousands of data points per second per sensor. Sensor data is sent to an IoT gateway, which filters the data, so less data is sent to the cloud. An example of a sensor gateway relationship is in an IoT connected car. A car is constantly generating sensor data from sources such as the air pressure monitor. Only when a problem arises is the data deemed meaningful and sent to the cloud via the gateway. Data is sent from the gateway to an IoT platform. The IoT platform is support software that connects everything in an IoT system. As of 2017, there were 450 distinct IoT platforms. There are expected to be over 1,000 very soon. An emerging IoT platform type leverages cloud-based technology. Sensor data collected is processed and analyzed by the platform and then further distributed to other devices. The overall concept of IoT, devices sharing data via a network, was discussed as early as 1982. Around this time, a Coke vending machine became the first internet-connected appliance. This took place at Carnegie Mellon University. This device was able to report its inventory as well as distribute beverage temperature data. The term IoT was coined in 1999 by Kevin Ashton. Although he coined the term, he is not the inventor of this concept, as the picture depicts him to be. He actually preferred the term Internet for Things in contrast to Internet of Things. In 2003, the ratio of objects versus people connected to the Internet was 0.08. There were 12.5 times more people than objects connected to the Internet. The ratio now is 1.84 in favor of the objects. It is estimated that between 2008 and 2009, the amount of objects overtook the amount of people connected to the Internet. Internet of Things is viewed as a technological revolution. Connection is now with everything, everywhere, every time, and everybody. IoT is generating algorithms to perform better analytics on big data. Big data pertains to large volumes of data that can be mined for meaningful trends. These trends provide valuable insight. IoT has sparked interest in machine learning. It has given rise to the machine learning movement. Machines learn as they go. These machines learn new functions by analyzing trends. The machines were not initially programmed to do the things they are capable of after analysis of big data.
How big is the Internet of Things? It's big and getting bigger. There are already more connected things than people in the world. Analyst Gartner calculates that around 8.4 billion IoT devices were in use in 2017, up 31% from the year before, and this will likely reach 20.4 billion by the year 2020. Total spending on IoT endpoints and services will reach almost $2 trillion in 2017, with 2/3 of those devices found in China, North America, and Western Europe. Out of that 8.4 billion devices, more than half will be consumer products like smart TVs and smart speakers. The most used enterprise IoT devices will be smart electric meters and commercial security cameras. Let's discuss some of the relevant IT components. The benefits of the IoT for business depend on the particular implementation, but the key is that enterprises should have access to more data about their own products and their own internal systems and a greater ability to make changes as a result. Manufacturers are adding sensors to the components of their products so they can transmit back data about how they are performing. This can help companies spot when a component is likely to fail and to swap it out before it causes damage. Companies can also use the data generated by these sensors to make their systems and their supply chains more efficient, because they will have much more accurate data about what's really going on. As you can see in the graph, IoT spending is heaviest in the manufacturing industry, with transportation and warehousing following close behind. Healthcare. In the healthcare sector, the possibilities with IoT are endless. The use of IoT-enabled medical devices has already taken the industry by storm. Although there are some security risks with these devices, the benefits outweigh them. IoT is a major component behind the rise of telemedicine or telehealth, in which medical professionals can stay in contact and monitor long-distance patients. In addition, hospitals are leveraging this technology to track patients and staff, and the technology is being used to reduce wait times in the emergency room. Restaurants. Just as IoT has practical applications in a home kitchen, there are also uses that can be leveraged in a commercial kitchen and on the front end of restaurants. The restaurant industry is using IoT to streamline communication, lower costs, and improve worker safety. Display systems can replace receipt printers, which eliminates some lag time. Smart refrigerators monitor when food spoil, and smart ovens can determine when parts need to be replaced before they break. Education. Educational institutions stand to benefit from numerous IoT applications. Schools are harnessing IoT to enhance more interactive web-based learning capabilities so that students can go beyond just what's in the textbook. Educators are using this technology to store vital records such as grades and attendance, which reduces the time it takes to find that data. More importantly, it is being used for additional school security with IoT-enabled communication systems that warn students about potential emergencies. Financial services. Despite regulatory compliances in the sector, the financial services industry appears to be embracing IoT. A 2018 report predicted that IoT in financial services will be valued at over $2 billion by 2023, and there are current use cases that are making its way around the industry. Insurance companies are using telematics to foresee and calculate potential hazards that might lead to a claim from a customer. Banks are experimenting with IoT-enabled security systems, including in ATMs, to prevent theft. The technology can also be leveraged to gather additional data about customers, providing more personalized offers. Energy. Although it is well documented that machine-to-machine communication can lower household energy costs, it can also redefine the entire energy sector. Instead of relying on legacy equipment, energy companies are leveraging smart grids that can improve security, capture data and analytics, and follow for quicker restoration after power failures. Additionally, a smart grid could lower our carbon footprint by managing energy consumption, and it could diminish the use of carbon emissions. Retail. IoT is transforming the way the retail market operates. In the front of the store, there are new automated checkout capabilities for customers. This solution decreases the time that workers would have spent as a cashier and instead allows them to focus on business needs and opportunities. There are also IoT applications in the back half of the store. Smart shelves track products to see which items the store is running low on and determines if an item has been misplaced. The technology also improves security by reducing potential theft. Thanks to IoT, workers in retail are more productive and stores are reducing some labor costs. Manufacturing. Out of all the industries that are embracing IoT applications, manufacturing might potentially serve as one of the best examples. Manufacturers are currently using IoT to monitor production flow during the entire process. With this solution, manufacturers have been able to track all of the events across the supply chain. Inventory is being traced down to each individual component, and that data collected from IoT devices allows manufacturers to gauge the quality of each item. The technology can also help with aspects such as packaging and improving worker safety.
I want to start to use the consumer service life cycle and how Internet of Things can help in one of each stage to create new value, and how the Internet of Things can help in each of the sub stages of the consumer service life cycle, as the requirements of the new products, the acquisition of the services of products, the ownership, how we can test, and the requirement of this. How Internet of Things help consumers and customers in the process. So Internet of Things can help in different stages, as I mentioned before. For example, establish the requirements, what we need to do, what we need, what is the our preference, what are the things that we can save, make the specification that what is the thing that we can do, source selection. For example, we can find in our cell phone, in our Google device, ordering products, the source of selection. We can order their authorization and payment with new technologies, so we don't use anymore, or we can not use anymore our credit cards or plastic. We use our cell phone to pay for this. How we can acquire the new products, testing and acceptance of it, and integration in our daily life. So Internet of Things can help in one of these stages and provide information to analyze and to support these activities. Here are some current uses by segment that we can find Internet of Things help in our daily life. I put four, but there are obviously more. First is home. We can find home security, monitoring our homes or the activities or family in our home, but the Internet of Things. With us only click on our cell phone, we can access to the webcam in our home, remote control of the temperature, light, AC, ordering groceries, or just leave to the new appliance connected to the internet order instead of going to the store, and save time to doing other things. In the retail activity, there are several things that Internet of Things can help, like a real-time price evaluation for consumer, business security as well, and video recording on consumer trafficking. So there are very application of the Internet of Things in the retail to save processes, time, cost, and very similar to the manufacturer area. So quality control reduction process, supply auto ordering, wage and salary control. So different very good resources to save time and create access anytime, anywhere. And in health and care area, health monitoring and hospital at home. So very current use by segment in the healthcare. Room and service availability, record and transfer data to patients. This is very important to save time moving records to one place to another place, one segment to another segment. And we can find more areas, but every one of these implement and adapt in each case how the Internet of Things can help. This is a very simple example of Internet of Things at home. Ordering by your Google device, turn on to light, ordering for us or dinner, regulate the AC. So it's very useful in some people. Maybe it can generate most cost. And I want to talk about the implication of the Internet of Things. So I mentioned it before. Sometimes the Internet of Things can generate a cost, a highest cost than before. For example, invest in new technology, develop expensive stuff. So not always the new technology is cheaper, but sometimes we need to evaluate this implication, the adaptability to the new products, not only the software, the hardware, but also the people dealing with the Internet of Things, and adapt the current system and hardware to the new technology. There are some additional related costs like a high-speed internet or 4G mobile data, because sometimes Internet of Things needs to be connected to all the products, appliances in our home or at the store. So maybe it's very important we need to stay connected. Easily access to the data, ability to analyze the information in current time or anywhere. So there are more implications, but every industry needs to evaluate the positive and negative implications of this. So thank you for this time, and we will continue on the next slides.
There are three main factors that affect the cost of implementing an IoT solution into a business, and they're ranked by percentage of cost below. We'll go through each of these individually. Hardware requirements, infrastructure complexity, and IoT solution size. Hardware requirements are the largest factor in cost estimation for implementing an IoT solution. Roughly 70 to 80% of the cost depend on this factor. IoT hardware is made up of smart devices that can acquire, process, and communicate data to the cloud. The 4 levels of IoT hardware requirements are outlined below. We have the asset, which is what we want to monitor or control. It could be anything from an autonomous vehicle to a wearable device. Then we have the data acquisition module. This device acquires physical signals and converts it into digital form. Next, we have the data processing module. This is basically a computer that processes data, performs analytics, and stores that data locally. The 4th hardware requirement, the communications module, communicates with third-party systems, either locally or in the cloud. In general, the more demanding the hardware requirements are, the higher the cost will be. Infrastructure complexity is the second largest factor influencing the cost of IoT app development. IoT infrastructure can include up to 3 components based on the business's needs. We have the network. It's highly scalable, wireless infrastructure. Some businesses only require this for their IoT solution, but often there's more needed. We next have middleware. This is third-party infrastructure installed on a network. Lastly, and the highest degree of complexity, includes cloud-based infrastructure. This involves a data center and it deals with storage solutions. In general, the more complicated the infrastructure system is, the higher the cost will be. The third factor, solution size, tends to affect the cost of IoT solution implementation the least. Solutions are categorized by 3 levels of scale: small, medium, and large. The larger the IoT solution is, the higher the cost will be. For example, the development of IoT solutions for smart home appliances tends to be less costly than that for self-driven vehicles. The benefits of implementing an IoT solution into a business can be grouped into 3 categories: efficiency, improved decision-making, and competitive advantage. We'll explore each of these individually. Efficiency. Through the power of IoT, monotonous tasks can be automated and done by machines, reducing time and energy applied. For example, a manufacturing company IoT solution could take the form of smart assembly lines capable of reporting errors in real time and adjusting the line accordingly. The end result of incorporating machines into the business is increased productivity for less inputs applied. The implementation of an IoT solution in a business tends to create improved decision-making. IoT solutions offer the business more data to analyze. With this data, trend analysis is allowed for, which catalyzes smarter decision-making. Furthermore, this data provides visibility into every aspect of the business. This tends to yield new insights and ideas. IoT allows businesses to understand customer needs better. This can often lead to new business opportunities. Additionally, the uniqueness of IoT solutions for the business creates a competitive advantage over rivals that is hard to emulate. Although IoT solutions do great things for businesses, there are still some risks involved in the implementation of those solutions. If you're paying attention to the news, you see things like the hacking of companies, stolen identities, and hijacking of app-connected cars. So we know that digital connected things definitely have security risks. To make things worse, many organizations don't have strong security protocols in place. Connected device manufacturers are often slow to update firmware or release patches, and may ignore security issues. Furthermore, we have data overload. IoT solutions generate countless bytes of data, but this is meaningless unless trends and patterns can be identified. To create value, businesses need a plan to process and analyze these huge quantities of data. Future IoT trends. Advanced AI software will provide real-time data streaming for IoT devices. This will help businesses extract meaningful insights and predict the most profitable outcomes. Furthermore, we will see significant advancements for the concept of smart cities. Moving out of smart homes, the IoT approach increases the quality of life, improves operations, and improves services rendered to citizens. And finally, we'll see the use of blockchain cryptographic algorithms, one of the most robust encryption standards currently available, for the protection of consumer data.